Hello students, in this video we'll discuss subsequences. If we're given a sequence, an, the index of the sequence is the natural numbers. So we have A1, A2, if we were just to write out the terms of the sequence, A3, A4, A5, A6, A7, A8, A9, A10, and it just goes on and on. A100, A999, A4210, etc. 4,210, it just keeps going. The objective or the idea behind the subsequence is that instead of indexing by n, you only pick a sub-collection of the terms in this sequence. So for example, I might choose A2, A5, A8, A100, A4210, and I forget about the rest of them. So a subsequence is a sub-collection, a sub-index of n. So a sub-index of n, so a subsequence, definition, a subsequence of our given sequence, an, n goes from 1 to infinity, is another sequence of the form a sub nk, where now k is indexed by n. And so what do these n sub k look like, where n sub k is itself a sequence from n to n, where, with the extra condition, with the condition that n1 is less than n2, is less than n3, is less than n4, etc. So let me give you a couple examples of these things. So for example, I could choose examples. We could say that n1 is 2, n2 is 4, n3 is 6, n4 is 8, and you're starting to see the pattern. And in general, we can choose n sub k to be 2k. And 2k clearly satisfies this condition. Another example is I could do this. I could choose n1 to be 1. Then I could choose n2 to be 2. So far, it looks like an ordinary sequence. n3 to be 3, looks ordinary so far. And I can choose n4 to be 5. Then I can choose n5 to be 8. Then I can choose n6 to be what? n6 will be 13. You can sort of see what I'm doing here. I'm basically just generating the Fibonacci sequence, right? And so over here, in general, nk is one of the terms, based on how I'm going to index the Fibonacci sequence, this will be what? This will be fk plus 1, right? So the terms in the Fibonacci sequence. And that also satisfies this condition because the Fibonacci sequence is increasing. Great, so that's a subsequence. And so now, what do we know? One major result about this is that if a sequence converges, so here's a proposition, if n goes from 1 to infinity sequence, converges to a point A, then any subsequence converges to A. Okay. How do we prove this? We prove this in the following way. Here's the proof. We let epsilon be greater than 0 and select n, which is a function of epsilon, such that an is less than an minus a is less than epsilon if n is bigger than or equal to n capital. Okay? Now the observation we should make over here is that we know that in general, nk for a subsequence is bigger than or equal to k. So nk is bigger than or equal to k because the terms in a subsequence have to form an increasing sequence. So that's great. So now what can we say? Well, now what do we know about a sub n k minus a? I claim that this is less than epsilon if this value k is bigger than what? If this value k is bigger than n. Because if k is bigger than n, this implies that n sub k is bigger than k is bigger than n. And so the n sub k is in what? N sub k is in the same regime as the n is in the original sequence, which implies that this inequality is true. And that shows that the subsequence a sub nk converges to a. So the subsequence is moving in some sense at a quicker rate towards the terms deeper in the series, in the sequence. So as I expect this, if a sequence converges, the subsequence is in some sense trying to get there a little bit faster than the original sequence. That's the intuition behind it. And the formal proof basically relies on the fact that n sub k is bigger than or equal to k. Thank you very much.